We must have discussed this. Till kinetic energy, I think we have already done. Four cases we were doing. Q V cross B was the formula of the magnetic force. Now, just tell me, first case we have done. What was the first case? Let's just revise what we have completed. Angle was 0 degree. You people haven't seen anything from magnetism. Please revise, at least manage with the notes. Just do the class notes at least. Okay, at least do the class notes portion. Otherwise, it will be very difficult. You don't write the notes, then see, you'll not be able to understand. I'll tell you, this will be very difficult if you don't revise. And if there's any trouble with any of the topics, then let me know. But without that, it will be really difficult. See, we were discussing the various angles. So first one was 0 degree. Second one was 180 degree. Then we discussed, remember this third one where I told you various formula were there which could be derived from this first one. Now here's a question that I want to practice with you, that I was asking about this topic. We didn't practice any numerical based on this. Or did we? We didn't, I think. There wasn't any numerical done from this topic, yes or no? No. Let me discuss it. See, this question says that a proton, a deuteron, and an alpha particle enter in a uniform magnetic field perpendicularly. So as soon as it is perpendicularly, this means this is your third case, right? If the charged particle is entering the magnetic field perpendicularly, then the magnetic field, this is the third case. Just a minute, wait. Okay. Yes. So see here, these questions come where you have to know a little bit relationship about the proton, neutron, and alpha particle. Okay, so if we have a proton present, neutron is there, proton, deuteron, and the alpha particle is there. Okay. Now see, you should know two things here. You should know the charge and you should know the mass. Okay, because we will be calculating the charge by masses ratio. Okay, so when we calculate the charge by mass ratio, we will be needing one common thing so that things can be cancelled out, right? So what we do, mass of the charge of the proton is E. The charge of the deuteron is E. Okay, and charge on the alpha particle is 2E. Okay. Similarly, when we talk about the masses, mass of the proton is mp. Okay, the mass of the proton is mp. Mass of the deuteron is twice the mass of proton, and the mass of the alpha particle is 4 times the mass of the proton. So this you should remember, because these are very commonly asked in the exam, and if you don't know them, then the cancellation will be difficult in the ratio especially. Otherwise it's easy, but in the ratios part it will be a little difficult. Okay, now a ratio of the radii if they enter with same velocity. Okay, ratio of the radii, radius formula we did, remember, mv divided by qb is the formula that we have discussed. So we'll be using this. That's why I said, see, velocity, mass, charge, magnetic field. We need mass and the charges. First part says if they have the same velocity. Okay. It says if they have the same velocity. Means R is equal to mv by qb. Look, mass is variable here because mass of proton is different, neutron is different, alpha particle is different. So this will be different. Velocity is the same. Why? Because the question stated that the velocity will be the same. Okay. Now charge on all of these are different. Charge on all of these are different. only neutron and proton have the same mass charges. No, otherwise it's different. So this is also variable. Magnetic field is constant over here. Now magnetic field is constant, velocity is constant, mass and charge are variable. So when I'll take the ratios, the velocity and the magnetic field will be cancelled. Basically, I can say the radius depends upon the mass by the charge. Now see, let me put all the values. So radius of proton is to radius of neutron is to radius of alpha particle. So radius of proton will be, see, mass of the proton is mp by the charge on the proton is E. Okay, is 2. Now coming to neutron, it is twice the mass of proton by same electronic charge. And for the alpha particle, it is 4 times the mass of proton by twice the electron. Okay. See, E will be cancelled. MP, MP, MP will be cancelled. So what is left from here? Look at the ratio. From here 1, from here 2, from here 4 by 2, that is 2. So 1 is 2, 2 is 2. This is the ratio. So same velocity, then this will be the ratio. Second part says same momentum. Now class, what's the formula for momentum of the momentum? Do you remember? Mass into velocity. Very good. So this part says this is same momentum. So momentum is equal to mass into velocity. Now see, from the formula, R is equal to mv by qb. So mv is equal to the momentum. So I can say R is equal to P by QB. Now let's look from here. Momentum, it's the same as per the question said. The charge particle, this is variable. Magnetic field, this is the same because the question stated it. Obviously, when all the 3 particles are in the same magnetic field, how it will be variable. So I can simply say that the radius is inversely proportional to the charge particle. That's it. So radius of the proton is to radius of the neutron is to radius of the alpha particle will be 1 by E is to 1 by E is to 1 by 2E. E will be cancelled. Look, half is coming in the denominator. I'll multiply all with 2 so that the denominator part is at least cancelled. See, you can write your answer as 1 is to 1 is to 0.5 also. That is also correct. Or you can write it like this, 2 is to 2 is to 1. I think this is a better manner to write. Now to just multiply and remove the denominators. That's when we have this. Third part says same kinetic energy. Okay. Third says same kinetic energy. Now look, kinetic energy's formula we have already done. Q square B square R square by 2m. From here the radius is 2 into mass into kinetic energy divided by. This is QB. Now let's look here what all things are variable, what all not are. Root 2, it's a constant. It won't be variable. It will be cancelled out. Mass, this is a variable term. Kinetic energy is constant. Why? Question said so. Otherwise, it's variable. It is constant here. Charge is variable. Magnetic field is also constant. So radius is directly proportional to this time. Root of mass by the charge. Right? Root of mass by the charge. Answer will be different. Let's see. This will be radius of the proton is to radius of the neutron is to radius of the charged particle. So root of mp by E is 2. Root of 2mp by E is 2. Root of 4mp by 2E. Look, E will be cancelled. Root mp will be cancelled. From here, 1 will be left. From here, root 2 will be left. See, root 4 is 2 and 2 by 2 is 1. So this is the third part. Same kinetic energy. Now fourth part says same potential difference. Same potential. Now look, in your dual nature of matter and radiation, there will be a formula that we will be discussing, that kinetic energy is equal to charge into the potential. So this is how the kinetic energy and potential are related. These questions are from your board exams, and in board the entire syllabus comes. So portions from dual nature are also included and kept, and they are considered. So that's why these questions are there. So now see, if we put the same thing in the radius formula, see, R is equal to 2m kinetic energy under root by QB. That will become root of 2mqv by qp. See, root of q, charge is coming double. Let's rationalize it. Let's multiply and divide it by root q. So what will we get? Root q into root q is q. Q will be cancelled. So 2mv by root q into b. This will be left. Now it is, we just have one q to solve. Two q's will confuse us unnecessarily. Now see, root 2 is a constant, this will go off. Mass is a variable. Potential is the same because the question stated so. Charge is variable, magnetic field is constant. So this time the radius is directly proportional to root of mass by charge. In the previous part, it was proportional to root of mass by charge. This is root of mass by charge in the second one. Means root of mass by root of charge. Both of them have the root sign. Now let's just take the ratio. Ratio of proton is to ratio of neutron is to ratio of alpha particle is under root of mp by e is to 2 mp by e is to 4 mp by 2 e. See, root of e, root of e, root of e goes, root mp, root mp, root mp goes. This is 1 is 2. This is root 2 is 2. See, this will also be root 2. Root 4, 4 by 2 is 2, and root is there. 1 is to 2 is 2, root 2 is to root. Yes, Halima, Oishi, Kutia, have you all understood this question?
Yes, ma'am.
Write down this question properly. I think fourth part we have already done the helical one. I'll just discuss it. Write this question. This is an important. Class, I hope it's done. Is it still writing?
Done.
Done?
Yes.
Okay, just tell me, I think we discussed this also? Fourth one also? Have we?
No.
Yes, Halima?
No.
No.
One we didn't do. Third case, till third case we did not.
Okay, till third case only we did. All right, let me continue from here. See, if the charged particle is at any angle apart from 0 degree or 180 degree or 90 degree, what happens means it is at a random angle in the magnetic field. So what we'll do, we'll resolve it into two components. Okay, because this is making some angle theta with the magnetic field, what we'll do, we'll be resolving it into two components. So the one which is adjacent to the axis will be obviously our cos component, cosine component, that is V parallel is V cos theta. And perpendicular to it is V sine theta. All right. So when you have the combined motion, when the V cos theta and the V sine theta combine together, what happens? This gives you a helical path. The cos component is responsible for the forward propulsion. Okay. And sine theta is responsible for the circular pattern. Then you have cos theta forward, sine theta circular manner, forward, circular, forward, circular. Eventually, this becomes a helical path, like a string. So this becomes a helical path. This comes as a theoretical part. You don't have any question. Usually, the questions used to be there earlier from this portion. Now, these questions are just included in your competitive exams like NEET, JEE and all, where pitch and everything is asked. But right now, what you have to know is you should be able to explain the theoretical part properly, that this is moving in a straight line, this is moving in a circle and all. Okay, so combined path is a helical path. Then coming to the Lorentz force, if the charged particle is present in such a field where electric field also exists, magnetic field also exists, both of these fields are existing. So the combined motion will be the sum of the magnetic field as well as the electric field. Means magnetic field is Q V cross B plus Q V cross B is from the magnetic fields component. Electric fields component is Q into E. So when we combine these two, charge is taken out, electric field plus velocity cross, the cross product of velocity and the magnetic field are left over here. Okay, so F is equal to FB plus FE, QV cross B plus QE, QE plus V cross B. They are present over here. Okay, so this is the combined motion, means when the electric field is also existing, the magnetic field is also existing, and the charged particle is present in the presence of both of these. See, earlier we isolated electric field, so we got Fe, that was Q into E. And then we took magnetic field, that was Q V cross B. Now what we're going to do, we are going to combine both of these. So for the electric field, the direction for a positive charge will be exactly in the same direction as that of the electric field. And for the negative charge, you reverse. This we have done in detail in electrostatics. When we started with it, when we were discussing the forces, when we discussed the electric field intensity, that time also I discussed with you that the charged particle will be parallel to the electric field, and the force on this charged particle will be in the same direction if it's a positive charge and negative if it's a negative charge. And for the magnetic force, I think we have done it a lot of times, the right hand thumb rule, right? So right hand thumb rule will be utilized. Let's practice one numerical based on this. So this will require a little bit conceptual knowledge of your cross product, which will be used in fact as it is. So this says a charged particle, 2 coulomb, is moving with a velocity I cap minus 2j cap in a region having electric field this much and magnetic field having this much. You have to find out the net. So see, we require V cross B. So let's first find out the cross product. What is velocity? Velocity is I cap minus 2 j cap. And magnetic field is I cap minus j cap minus 5 k cap. Okay, now see, when we take the cross product V cross B, what you do, put I cap, j cap, k cap like this for the cross products. And then write the coefficients of each. Velocity will be, see, this is 1, j cap's coefficient is minus 2, There is no k cap, so the coefficient is 0. Then coming to the magnetic field, coefficient is 1, j cap's coefficient is -1, k cap's coefficient is -5. So this is the determinant system that is required. Now what we do, we put the cross product. What we'll do for the I caps component, we're going to cut the row and the column of I cap. Then we multiply this diagonally down minus diagonally up like this. Means -2 into -5 diagonally down minus then diagonally up -1 into 0. So this much will be I cap. Okay, diagonally down minus diagonally up. That's the rule for it. For j cap, put a negative sign and then you can follow the same rule. Otherwise, you'll have to reverse it. So it's better just put a negative sign and then solve it. Then you cut the row and column for the j cap. So this again vertically down minus vertically up in this manner. Okay, so that makes it 1 into -5 minus 1 into 0. This much of j cap. Okay, finally plus. So we cut the row and the column of the k cap. Okay, k cap is gone. Now what we do? 1 into -1 vertically down, sorry, diagonally down minus diagonally up means 1 into -2. This much of k cap. So at least we will get our cross product. See from here what it is. This is 10. All this is 0. So 10 I cap. This is -5, 0. So plus 5 j cap. This is -1. This is -2. Right? -2 into 1 is -2. This is -1. Minus minus will become plus. So 2 minus 1 is, so that becomes plus k cap. Right? Plus 1. This becomes plus 2. 2 minus 1 is 1. So plus k cap. This is just our V cross B. Then what do? We add electric field plus this V cross B. Now electric field is I cap, 2 I cap minus 3 j cap. 2 I cap minus 3 j cap. And then you add this V cross B. This is the V cross B added. 10 I cap plus 5 j cap plus k cap. So this will be 12 I cap plus 2 j cap plus k cap. And then finally, what do? We multiply charge with all these things. Q into E plus V cross B. That is given as 2. So 2 into 12 I cap plus 2 j cap plus k cap. So finally, the net force we can say in this case will be 24 I cap plus 4 j cap plus 2 k cap. This much of Newton is the final answer. Yes, is the Lorentz force clear to all?
Yes.
Oishi, is it clear to you? Kotsia, clear?
Yes.
This question you copy, but before that, take the screenshots for the fourth case and the Lorentz force one. Okay. From here, this comes in the theoretical part. This has come recently.
Ma'am, can you scroll up 1 minute? Okay, ma'am.
Okay, done. See, force of a current carrying conductor in the magnetic field. See, you have a current carrying wire present, electrons are moving and the current is moving in the opposite direction. So volume of the conductor is area into the length. So total number of electrons will be the number multiplied to the volume so as to get it for the full wire, right? Now, from the quantization of charge we have studied, charge is equal to the number of the electrons multiplied to the electronic charge. So Q is equal to NEAL, total charges that are present. Correct. Now see, what did we study? Force is equal to Q V cross P. Let's put it. Q is E, that is this NEAL. NEAL. The velocity with which the electrons move is the drift velocity into the magnetic field, right? Now look from here, if we extract NEAVD, there's a formula. NEAVD. What is it equal to? Just tell me this. We have done this. NEAVD is equal to, tell me.
Correct.
Very good, Rishi. This is equal to the current. So I is equal to NEAVD. This is equal to the current. So the formula becomes C. If we replace I here, that becomes, this will become then I L cross P, which is equal to BIL sine theta. Usually sine 90 degrees is given. So like this, if this is a wire present, magnetic field is 2 Tesla, length of the wire is 2 meter, and current flowing is 5 ampere. So when we write the force, force will be BIL sine 90 degree, because magnetic field and the length are perpendicular to each other, class. Magnetic field is 2, current is 5, length is 10. That is equal to 100. Now look, direction. Wherever the current is flowing, take your right hand. Wherever the current is flowing, put your hand in that direction. Now current is flowing towards the right. We'll put our right hand towards the right side. Now where is the magnetic field? By looking at the cross, it is predictable that magnetic field is inside. So curl the fingers inwards. Thumb points upwards. That is J cap. So 100 J cap Newton is the final answer. Like if I change the orientation of the wire like this, look, current is now, if I write F is equal to BIL, again this is sine 90 degree. Magnetic field is 2, current is 5, length is 10, that is 100. But now look at the direction. Current is up, magnetic field is outwards this time. Look, the magnetic field is outwards. So outwards means this. Thumb points towards the right. That is I cap Newton. Is this formula clear? Is it? This topic done? Okay. Write it. Major portion is over from this chapter. Some small topics are now left. Parallel wires, torque, and then the final one. Okay. Don't write this. Just take the screenshots of this and just write the numerical part. We'll proceed towards the next. Okay, so the last topic for today. Then I think in the next class we'll be completing this. This chapter will be done in the next class. Okay. So force between two parallel wires basically means now this is a specific case for two parallel wires only. Okay, means we have studied the force for a single conductor BIL formula, BIL sine theta. What if two parallel exact same parallel wires are present with a certain gap between them? Both of them have certain amount of current flowing. I1 is the first wire, I2 is the second, length is L, and separation between them is D. Now, magnetic field on the second will be, force on the second will be caused due to magnetic field of the first wire. It is only influencing of the second field to have a force, to exert a force. Similarly, when you're calculating the force on the first wire, magnetic field will be due to the second wire. Just remember this. That's all in its derivation. We already know for a long wire, mu naught I by 2 pi d, infinitely long wire. Long you say, infinitely you say. Formula is mu naught I by 2 pi a, the formula which we did. So if we apply it here, let's say we are calculating force on the second due to first. So due to which? Due to first means first is having the magnetic field that is present. So B1 is equal to mu naught I1 by 2 pi d. So F21 is equal to B1 I2 L. Put the value of B1, I2 is there, length is L. So formula becomes mu naught I1 I2 L by 2 pi d. Okay. So 1 2 will become mu naught I2 I1 L by 2 pi d. Same thing. Like for the second, first on the second, what will be the difference? You will be using I2 here and I1 here. Eventually, when it will be multiplied, it will give you the same formula. Right now, if I bring this length in the denominator, if I bring up this length in the denominator, that is known as force per unit length class. It is represented by small f, force per unit length. Okay, so we can use the formula force per unit length as mu naught I1 I2 by 2 pi d. This can also be used. So force on the first due to second, second due to first can be written like this. They have the same magnitude, direction is opposite. Now how to identify the direction? See, if the wires are flowing in the same direction, they attract each other. Both of the wires will be moving towards each other like this. Look at this figure. Both of the wires will be moving towards each other. So this way you can predict the direction where the other wire will move due to the other. And if they are moving in opposite direction, means one up, other down, or the second one up, first one down, then they repel each other. Okay, that's one thing that you need to remember. Now a question comes, define 1 ampere in terms of the force between two parallel wires. See, usually when 1 ampere comes to define, you know what you have to write? You have to write all the content from your current electricity part. Okay, you have to write everything from your current electricity portion. What is 1 ampere? When 1 coulomb of charge flows through a wire or a cross section of a wire in 1 second. But when it specifies from this chapter, that means force per unit length is equal to mu naught I1 I2 by 2 pi d. I1 and I2 they are equal to each other, which is equal to 1. Okay, I1 is equal to I2, which is equal to 1. Separation distance between the wires is 1 meter. So mu naught by 2 pi will be equal to, see, mu naught is 4 pi into 10 to the power minus 7. This is by 2 pi. So force per unit length becomes 2 into 10 to the power minus 7 Newton. So 1 ampere is the current when flowing through two long conductors separated by 1 meter gives 2 into 10 to the power minus 7 Newton of force and can attract or repel each other. Okay, so this is how you can define 1 ampere. Like, look, a very basic question. Two wires are there. One has a current 2 ampere, other has a current 10 ampere. Both have a distance separated as 2 meters. Now, when we calculate force per unit length, means 2 due to 1 or 1 due to 2, like this when we'll calculate. So, see, mu naught I1, I2 by 2 pi, D is this. D is 2 meter, I1 is 2, I2 is 10. So, F21 will be mu naught I1, I2 by 2 pi D. Put the value 4 pi into 10 to the power minus 7 into 2 into 10 divided by 2 pi into 2. Similarly, for F12, it will come out to be 2 into 10 to the power minus 6 only. But directions are different. See, both of them are moving towards each other because they'll be attracting each other. both the wires, they'll be attracting each other. So this wire will move towards the first will move towards the second. So for the second one, you are going to put the direction as minus I cap. The first one, you're going to put the direction as plus I cap. That's the difference. Okay, so this also comes in the exam. Take the screenshots and just note down the numerical. Any of doubts from the assignment, Soishi?
No, ma'am. I just did like a few questions and I have a few doubts.
Is it from the portion that we have already covered in the class or the entire chapter somewhere else?
It's related to refraction itself,
Then
like
tomorrow
prism.
let's discuss. Tomorrow we will be having the class with the batch. It's Thursday.
Okay.
No?
Okay.
Tomorrow let's discuss.
It's related to refraction and prism, like that.
Okay, okay. Tomorrow let's discuss then.
Okay.
Okay, class. Now see, just one class is needed. I have to discuss torque with you all. Conversion of galvanometer and ammeter and magnetic dipole moment. Okay, so that will just need one class. So in the next class, I'll be completing this chapter and freshly we'll start with fifth chapter in the next chapter. Okay.